Hello, sixth graders. My name is Mr. Burns, and I am the science teacher in the boathouse. And today we are going to take some notes on matter and the three states of matter. What I'm going to have you do is grab your science notebook out and open it up to your table of contents. All right, we're going to update your table of contents with page 37. What I want you to do is copy in today's date, which is 1-11-21. And our topic is matter notes, page 37. If you want to put that into your table of contents now. Then as you finish that, I'm going to have you go to page 37, and at the top of the page, title page 37, matter notes, and you can add our date in, again, 1-11-21, and 37 at the bottom. As we move through the notes today, just a couple reminders for you. As usual, anything that you see highlighted in yellow, you should copy into your science notebook. Okay? As I'm moving along, and if I'm going too fast for you, pause the video, finish up your writing, and then start the video up again. All right, first I'm going to have you copy in our definition for matter, which is highlighted in gold. And matter is anything that has weight, mass, and volume. It takes up space. As we look at these pictures, or three different states of matter, the solid, liquid, gas, the thing that they have in common, not only are they matter, but all of them have weight. From the solid, which looks like an ice cube, to the glass of water, to the gas there, and all of them take up space, so they would be great examples of matter. All matter is made up of tiny particles called atoms and molecules. And we learned that last week when we were talking about atoms and molecules. So whether it's a chair that you're sitting in right now, or the pencil that you're writing with, it's made up of atoms and molecules. The state of matter is determined by how fast the atoms and molecules move and how strong the particles hold together. So certain atoms move faster or slower than others, and that helps to determine what state of matter it is, as well as how strong the particles hold together. Some are held together very strongly, some are a little bit more weaker, and that helps to determine the state of matter also. And as we move through this today, we'll expand upon each of those two items. So there's three states of matter that we focus on: solids, liquids, gases. Those are the three primary states we'll focus on throughout the unit. And what you're looking at there is the particle arrangement of a solid versus a liquid versus a gas. So as you look at the particles that are inside those containers, although they look similar, you'll notice some slight differences between what a solid looks like versus a liquid and a gas. Kind of keep that in the back of your mind, because we'll talk more about that here in a moment. First, we're going to focus on characteristics of solids. So these are characteristics that all solids have in common, whether we're talking about a pencil, or we're talking about a piece of paper or a chair. These are things that they all have in common. Okay. First of all, the particles that make up a solid, you can see a picture of them over to the right of the screen there. When we're talking about their movement, they simply vibrate in place, and they do that because they're so tightly packed together. If you look at each of those circles, there's not a lot of room there for them, so they can't really move around much, and they just simply vibrate in place because they're tightly packed together there. The attraction between the particles in there is really, really strong, and as you can see that they are close together, which means that they are there's a strong attraction between them. Volume. Yep. All solids have volume. In other words, we can calculate how much space they take up. It's easy for us to see them, and it's not too difficult for us to calculate how much volume they have. Shape, most solids have a shape, or shape that they closely align to, so that they are maybe circular in shape, or square in shape, or ovalish in shape. If you look at the spacing between the particles in that picture, there is very little to none. I mean, they're kind of in contact with the other particles around them. And then from an appearance standpoint, it's organized. You can kind of see, in this particular picture, you can kind of see columns as well as rows, and they are packed in there tightly. And these are characteristics that all solids have in common. When you finish writing down what's highlighted in yellow there, then the next thing you want to do is draw a picture of what you see on the right-hand side of the screen. This picture is used to show what the molecules of a solid look like. Next, we'll move into characteristics of liquids, whether it's water, or it's orange juice, or it's milk, Gatorade. These are characteristics that all liquids have in common. When we're talking about the characteristics that make up liquids, and specifically the particles in there, those blue circles that you see in the picture there, as far as them moving, they're able to slide past each other. You can see some spacing in there, the white background, and that's what allows these particles to move around a little bit. As far as their attraction, we call that medium. It's not as strong as a solid. Okay, so it's more weak than a solid. It's kind of a medium amount. They're not as attracted to each other quite as strongly. Volume, yes, definite. In other words, we can find the volume of liquids. We can measure that out very easily. Shape, no, takes the shape of the container. Liquids don't have a true shape to them. I always call them shapeshifters because they will take the shape of whatever you pour the liquid into. If you pour it in the cup, it'll take the shape of a cup. If you put it in a bowl, it'll take the shape of a bowl. The spacing between the particles, it's loose, relaxed, as you can kind of see in the picture there. And then the appearance of them is disorganized and flowing. They're not all lined up in columns and rows like we saw with the solid. So those are kind of characteristics that all liquids have in common. When you finish copying down the highlighted information there, I'm going to have you draw a picture of what liquid molecules look like. You want to draw what you see on the right side of the screen there. Try to be as accurate as you can. All right, our third state of matter is gas, and we're going to focus on characteristics that gases have in common. So when I'm talking about gas, I mean things like oxygen or helium or hydrogen and so forth. So as far as how the particles move within gases, their movement is fast. They're extremely quick moving in comparison to liquids and solids. The attraction between the particles is very little. There's not a strong attraction between them. It's pretty weak in general. Volume, none. It changes with pressure. Shape, nope. Takes the shape of the container. Spacing of the particles, far apart. You can see that in the picture there, how much space there is between them. And in their appearance is that they're widely scattered. There's no, unlike the solids, there's no columns or rows. You see a lot of space, and they're just kind of scattered apart. As you finish copying the highlighted information above, then you want to draw a picture of this gas molecule in the circle. So below your information that you're writing down, you want to copy a picture of what you see on the right-hand side of the screen. Try to be as accurate with it as you can. All right, to wrap things up, we just want to focus on the movement of the molecules and their appearance here. Again, you want to copy anything you see in yellow. And as we look at the picture there, we have the three states of matter side by side, the solid, the liquid, the gas. And a couple things that we're trying to point out there from an appearance standpoint, you can see how the molecules are tightly packed together, which is symbolic of solids. and that they move very slow. They're the slowest moving types of molecules. Remember, they just kind of vibrate in place. And as we move to the liquid, you can see that the molecules are spread apart a little bit more. They're not so tightly packed together. And as a result of that, they're able to move a little bit faster. They move at kind of a medium pace or an average type speed. And then as we go to the gas on the right, we see the molecules are spread apart even further, and they are the fastest moving types of molecules. So again, the goal here is just to kind of look at the difference of how the molecules are arranged from a solid, liquid, gas, as well as how quickly they move. And that is it, sixth graders. I hope you have a great day. Bye.